All right, so today we're going to be looking at parabolas, which is probably the only conic you've spent any amount of time already studying. We're going to look at it through the perspective of a focus and a directrix today, though, instead of how you probably have looked at it in the past. I don't know, in Algebra 2, did you talk about focus and directrix at all, or not really? Not really. Okay, that's all right. So basically, I'm just going to give you a new form for a parabola. You've already graphed lots of parabolas in Algebra 1 and Algebra 2. But we're also going to be looking at parabolas that open to the left and to the right, in addition to ones that open up or down. So just like with all the other conics, there's going to be two different types of equations here where they're very closely related, but it kind of depends on how the focus and the vertex are all aligned, vertically versus horizontally. So I'm going to give you a couple diagrams, we'll do some examples, and just kind of do the same thing that we did with the other conics. So let's start with your normal parabola, right? You've graphed lots of parabolas before. Typically they open up or down, but I'm going to give you sort of a new way to look at it. So in your parabola, you've got a point called a vertex, which I'm just going to draw like that. Okay. And a line called a directrix. And this is really all you need to define a parabola. So we'll get into more detail on this next time, but all of the points on a parabola are equidistant from the directrix, which is this line, and a point called a focus. Okay, so the focus is going to be we'll say right here. Well, I'm not sure what I want to label this yet. I'll come back to that. So you have a focus, a directrix. I guess I can do it like this. And then this point right here is called the vertex. I'm going to leave that blank for now. So if all of the points are equidistant from the focus and the directrix, what I'm saying is that this vertex, for instance, has to be the same distance from the focus as it is the directrix. So that distance is always going to be the same. Okay, we're going to call that distance P. So the distance from here to here is P. The distance from here to here is P. So that whole distance, from the focus to the directrix, is 2P. So we can plot other points on this parabola by keeping that in mind, as far as okay, well, we know that all the points need to be equidistant from this point in this line. So if I were to go from the focus sort of parallel with the directrix, so go left and right here, how many units would I need to travel to get to a point on the parabola? In other words, if I know that my parabola is going to do something like this, right? It makes a U shape, right? But how many units would I need to go out to get another point on the parabola here? In other words, what's this distance right here have to be?
Isn't that the hypotenuse of a triangle that's just made up of two diagonally?
Okay, so you sort of answered my question within your question. What would this distance have to be? 2P, right? The reason why it has to be 2P from here to here is because we already know this distance right here, right? This is 2P. So the distance from the focus and from the directrix is equal for every single point on the parabola. Now for when we graph these parabolas, I'm only going to require that you graph 3 points. The vertex, and then these two other points that are aligned with the directrix. So if I go 2P units this way, I can find a point. And if I go 2P units to the left, I can get another point. All right, this is 2P. And then once I have those three coordinates, I can draw my parabola like this. So let me give you the equation of this parabola. You already know it's going to be a quadratic. You've done that a lot before. But I'm going to write it a little differently. And this time, instead of giving you an a value, I'm going to write this in terms of the p value, so that you will know where the directrix and the focus are. So here's the equation for a parabola that has a horizontal directrix. Y equals 1 over 4p times x minus h squared plus k. So this is very similar to what you learned like in Algebra 1, Algebra 2, to the vertex form of a quadratic, where you have the vertex hk explicitly stated in the equation. The only difference here is instead of just some arbitrary a value here, we've got 1 over 4p, where p is this distance right here. So a lot of times when you're graphing these, like if I give you an equation like this, your first step is going to be to identify h, k, and the p, and then you can kind of go to work plotting everything out. Any questions about that one? So one thing to note is if, this could open up, but it could also open down. You've seen parabolas that open down. And do you remember like what causes that to happen? Like a flip in the parabola. Something's positive or negative, right? And so back in Algebra 1, you learned that this a value controlled that. If the a was positive, it would go up. If the a was negative, it would go down. But we don't have an a value here. We have a 1 over 4p. But that p can sort of play the same role. Okay, so I'm just going to make a little note here. If p is positive, the parabola opens up, just like in this diagram. But if the p is negative, then the parabola is going to open down. So it could open up, could open down. It all depends on if this number right here is positive or negative. Now in Algebra 1 and Algebra 2, that's kind of where you stopped, right? You graphed quadratic functions. But we want to look at parabolas that are also maybe not functions, where y is not a function of x. And those are ones that open to the left and to the right. We can still define a parabola in the same way, where it's all the points that are equidistant from a directrix and a focus. But if we draw that directrix vertical, then the parabola is going to open left or right. So most of this diagram is going to be the same. I'm just going to basically draw it like this. Okay. So we have our directrix, except this time it's vertical. We've got a vertex somewhere and a focus. Again, these distances should be equal. In fact, it's p. And then I'm going to graph this parabola sort of the same way as I graphed the other one, where I go from the focus, 2p units up and 2p units down, to find 2 more points. Basically, I'm sort of envisioning a little square here. This distance is 2p. This distance is 2p. And once I have those 3 points plotted, the vertex and these 2 other points, I can draw my parabola. What do I not have labeled here? Oh, here's the vertex. So the equation for this kind of parabola that opens to the right or opens to the left is going to look very similar to the the other one, except the x and the y stuff is all going to be reversed. So this equation is going to be x equals, instead of y equals, 1 over 4p times y minus k squared. Notice how the k sort of sticks with the y and h sticks with the x, plus h. I don't think I wrote it anywhere on here, but the hk, which represents the center for the ellipse and for the hyperbola, in the case of the parabola, hk represents the vertex. So that's definitely something to keep in mind. I'll write that somewhere up here. hk is the vertex. Now, just like with the parabola that has a horizontal directrix, the one that has a vertical directrix can open either right or left depending on the p-value. If the p-value is positive, then just like with the other one, this is going to open in the positive direction. If the p is negative, the parabola will open in the negative direction. So if p is positive, the parabola opens to the right, like we have drawn here. And if p is negative, it'll open to the left. So let's do an example then. Let's say I've got x plus 2 squared plus 16 times y minus 4 equals 0. Say, okay, go ahead and graph that. What's your first reaction here? Graph that. The what? Yeah, this whole thing is like sort of not in the right form, right? What you want to do is make sure that either your x or your y is isolated. And when you're trying to decide like which one should you isolate, you want to go with the linear term. In other words, like leave the squared stuff as is and just mess with everything else. So in this case, if I want to solve for y here, I'm going to start by bringing this squared thing to the other side. So I'm going to have to do a little bit of algebra up front here to make sure I can actually calculate this, the p, the h, and the k. So I'm going to subtract x plus 2 squared from both sides, just really in an attempt to move it to the right-hand side. So now I've got 16 times y minus 4 equals negative x plus 2 squared. What would be my next step? Divide by 16. All right, so I'm going to divide both sides by 16. And so now I've got y minus 4 equals negative 1/16 times x plus 2 squared. So I'm getting a little closer here. The last thing to do is going to be to add this 4. So I get that on the other side as well. So my equation, now that I've got it sort of in the right form, is going to be y equals negative 1/16 times x plus 2 squared plus 4. All right, now I'm in a little bit better spot here as far as, okay, now I'm ready to graph. Before I start sketching out a graph, though, let's identify all of our parameters. So, like, what is my hk? Where's my vertex going to be? What's the h? We'll start there. Negative 2. And then you want to be careful with the k. This number out here is not going to be the opposite sign. So the k here is just positive 4. Oh. Here's where it gets a little tricky. What's the p-value? Well, if this constant right here, this coefficient to this squared binomial, is negative 1/16. I'm going to just do a little side work out here. And I know that that has got to be 1 over 4p. You can solve this out by cross multiplying, or you can just kind of think about it. What would p have to be to make this true? Yeah, negative 4, right? Negative 4 times 4 would be negative 16, and then you'd have what you need. So if that's not as obvious to you, you can always cross multiply and then solve for this variable, but otherwise, this is the way to go. P is negative 4. Okay, so I've got my p value. Okay, so before I start graphing anything, I've got a couple questions. One is the directrix going to be horizontal or vertical? And how do you know? What do you think, Abe?
How is p negative 4? Because you're multiplying p by 1/4.
So p is in the denominator. It's not 1/4 times p. It's 1 over 4p. Yeah, good question. Let me make sure I think I wrote it. So yeah, how do I know which way the directrix goes? Vertical or horizontal?
So we have a negative, or a fraction thing where p was is negative, so wouldn't it be going down?
So, okay, so you've got the right answer to a question I didn't ask, right? But you're right. But my question is the directrix horizontal or vertical?
It's vertical because y is the thing outside of all the...
So if I have y equals, then my directrix should be horizontal.
horizontal.
Yeah. So I've got a horizontal directrix. I'm just going to make a note here, horizontal directrix. So when I go to sketch, I don't have to worry about that later. I've got a horizontal directrix, and just so I know, so when I start putting everything together, this is going to work out, which direction will the parabola open, up or down? Down, right? And I know that the parabola is going to open down because the p value is negative. Okay, so it opens down. And that's just to sort of like make sure once we start sketching, we've made a couple of notes here, what we're expecting to happen, so that we can make sure to be accurate with our graph. So I'm going to go ahead and start putting some stuff down on paper here. All right, so my vertex is at negative 2, 4. So I'm going to plot that 1, 2, 1, 2, 3, 4. There's my vertex. My p-value is negative 4, and that's what we're going to use to plot both the directrix and the focus. I know that I've got a horizontal directrix, and I know that it opens down. So if it's going to open down like this, will the directrix, that dotted line, be above the parabola or below the parabola? I'm sorry, above the vertex or below it? Above, yeah. So I'm going to go p units, 4 units, up to sketch out the directrix. 1, 2, 3, 4. All right, so in this case, the directrix is at y equals 8. And what about the focus? That's going to be 4 units below the vertex. So 1, 2, 3, 4. Focus is right here at, what is that, negative 2, 0. Now to get the actual parabola correct on here, to make sure your width is okay, because we know you can have lots of parabolas that like are skinny or more that are wide, you've got to plot those 2 other points. And so to get those, you're going to go 2p units from the focus to the left and to the right. So how many units do I need to travel to get those points? Like from the focus, how many do I go to the left? 8, yeah. So I go 1, 2, 3, 4, 5, 6, 7, 8, and plot that point. 1, 2, 3, 4, 5, 6, 7, 8, plot that point. And so now I have enough for my sketch which is going to go like this. So we've got pretty much everything here: the vertex, the directrix, the focus, the graph. We're good to go. All right, let's say we have something like x plus 2 equals 1/8 times y minus 5 squared, something like that. So this one's kind of set up already. You just have to do a little tiny tweak here to get it in that form that you want, and that is to subtract 2 from both sides. So we've got x equals 1/8 times y minus 5 squared minus 2. Where's my vertex? Where's my HK? Remember, when it's an x equals equation where you have a vertical directrix, the HK are sort of reversed. Like the H is already sort of paired up with the x, the K is with the y. So where is my vertex? Yeah, good. -2, 5. Okay. And what's my p-value? If this thing right here is 1/4p, then what's p? 2. Since this is x equals, which direction is the directrix going to go? Is it vertical or horizontal? Okay, it's vertical, right? So vertical directrix. And I'll make a note. I'm not sure what it is yet. It's usually easier to get it from the graph, but I'm going to leave a little space here to write the equation of my directrix. And which way is it going to open? Opens to the right, because that p-value is positive. So now I'm ready to start sketching out here. I've got my vertex at -2, 5. 1, 2, 1, 2, 3, 4, 5. I know it opens to the right, so that means my focus is to the right, my directrix is to the left. So the directrix is vertical. I'm going to go 2 units to the left to plot the directrix, and 2 units to the right to plot the focus. Now I can write now I can write what those are. Right, the directrix is going to be x equals -4, and the focus is going to be at 0, comma, was that 5? Yeah. My p-value is 2, so I can go 2p units, which would be 4, up and down, starting from the focus. So 1, 2, 3, 4, 1, 2, 3, 4. And then my parabola will do this. Almost got it.